Good morning or afternoon, geometry students. So today we're starting a whole brand new unit, chapter 9, which is what we were going to start right after the 3-day weekend that turned into somehow a 6-month weekend. Um, this section is called translations, but the broader topic of the unit is called transformations. We'll talk about that in just a minute, but take a minute to write down your learning target, please. I can identify a rigid motion, and I can perform a translation given a rule and a pre-image. That sounds like we're not speaking English. I promise I will define those words on the next slide. So pause the video if you need to and write down your learning target. Okay, so we have a few pieces of vocabulary that are going to be important for the whole entire unit. So these pieces of vocabulary kind of form our larger umbrella. And then underneath the umbrella, we're going to learn some specific types of transformations each day. So the first word we need to know is this word transformation. So when I think of transformation, I have been watching HGTV a lot with my husband lately because, as you can see, we are in a new house in Alabama, and it's just fun to get some ideas. But all these shows on HGTV are about transforming these houses, right? They take this old crummy house and turn it into something beautiful. Um, Another thing that I think of when I think of transformations is like a makeover, right? You take someone and you like their makeup or give them a haircut or put new clothes on them or something, and they say, oh, look at their transformation, right? So that's kind of the idea of the week or of the unit really, is that we're taking something, and in our case, we're going to take geometric shapes, so triangles or squares or circles or hexagons, and we're going to change them into something different. Okay, so the official definition is that it's a function or a mapping that results in a change, and that important word right there is change, right? In the position, shape, or size of a figure. So the next word that's important is this word, the pre-image. And then also, actually, I'm going to put up the images kind of goes along with it. So pre-image and image are two words that we're going to use for almost every single shape that we talk about in this whole unit. So a pre-image, I usually define that as kind of like the starting point, right? So I'm taking a shape and I'm going to change it into something else. The pre-image is what we start with. So it's the original figure in a transformation, and we just call it by its points, A, B, and C. Okay, so if it's a triangle, it'd be triangle ABC, or a rectangle, ABCD. The image is the resulting figure after a transformation, and we use this notation with these little quote marks, A prime, B prime, and C prime. That just tells a mathematician that it's not the original figure, it's a new thing. You've taken something and you've changed it. So A prime, B prime, and C prime. That's something that if I was in class with you and people raise their hand and say, oh, we're moving it from this to that, and you call it ABC, I would gently correct you very frequently in class just to kind of get our math language down, right? This is a language that mathematicians use. We call the new triangle A prime, B prime, and C prime, not just ABC. The final definition is a rigid motion, and there's a word right behind where my face is right now that says it changes the location of a shape. So a rigid motion takes a shape and it changes it to somewhere else, to a new place, but it doesn't make it bigger or smaller. So it doesn't change its size. So pause the video here if you need to take a minute to write these down, and then we'll talk about how do we use these in examples. So today, or this week actually, we're going to talk about 3 different types of transformations, and we're going to focus on rigid motions this week, which means that they're changing locations, but they're not getting bigger or smaller. We'll talk about bigger and smaller changes next week. But for now, everything's staying the same size. So the first one that we're focusing on today is a translation, and I put kind of English layperson words underneath each of these. I think of a translation as a slide or a glide or a shift. So I take my triangle and I'm just moving it to a new location. It's not turning, it's not flipping, it's not doing anything fancy. It's literally just like going from here to here. It just moves. Okay. Reflections and rotations are exactly what they sound like. So a reflection is like a flip. So think about like in elementary school when you do symmetry. If you draw a line of symmetry down the middle and then you flip it across the line of symmetry, it kind of creates this exact same shape, but just flipped like a mirror. And then a rotation, exactly what it sounds like. We're just turning a shape. So I take the shape and I turn it to something new. So again, nothing got bigger or smaller. They're just moving locations on the paper. So a translation, this is the focus of today. And by the way, if you needed more time on that last slide, go ahead and go back and write it down before you watch this new one. But the official definition of a translation is a transformation that moves points, get ready for this, the same distance in the same direction. So I'm taking all of my points and I'm moving them all the same direction to the right or to the left, and then I'm moving them all the same direction, up or down. So everything I'm taking, I'm doing the exact same amount. We have this kind of fancy notation, and this is something that's not an 8th grade standard. You wouldn't see this in 8th grade math necessarily, but we use it a lot in geometry. You won't need to know how to create these rules, but you do know how to, you need to know how to interpret them and how to use them. So the T in this notation tells us that it's a translation. So you'll see kind of up at the beginning of these rules that we're going to start to use, there's always going to be a letter right there at the beginning. And that letter just tells us, are we translating? Are we reflecting? Are we rotating? What are we doing? So T tells us it's a translation. Then you're going to see these little arrow bracket type of things. The X, think about the x-axis on a graph, tells us kind of how we're moving side to side, so left or right. And then the y tells us how far we move up or down. So if you see numbers there, if it was like a +5 on x, we're moving 5 to the right, and my directions are all backwards here. And then for y, if it's a positive y, we move up. If it's a negative y, we move down. I'll show you in the next example here. When we have in parentheses the A, it's not always just going to be a letter. Sometimes you'll have a point there. Sometimes you're going to have an entire shape there, but that's kind of what we're starting with. And then the A prime after the equal sign tells us that that's our image or our ending point. So after we do all this translation stuff to it, we end up at this shape, okay? Take a minute to write this down because this is kind of important. You're going to want to be able to refer to this when you're doing your assignment. So quick example here. We take a look at this rule. So I'm kind of just trying to get you used to interpreting these rules. So we take a look at this. It says T and then in brackets 5, -4, and then in parentheses XY. And we want to know, what does this mean? So that first letter that's there, the T, just automatically tells that it's a translation or a shift, which means that we're translating or moving the point XY, right? So see how we have this XY at the end. So it means we're translating that point XY, okay? And then the 5, -4 tells me that I'm moving 5 on X and 4, -4 on Y. So that means on the X axis, I'm gonna move all my points right 5. And on the Y axis, I'm gonna move everything down 4. So if I have a point here, I'm gonna move it 5 to the right and then 4 down. Every single point in my shape, if I had a triangle or a square, is gonna move 5 to the right and 4 down. So really quickly here, just kind of thinking about rigid motions and not. In number 1, it tells us to determine if each preimage and image represents a rigid motion. If it is, tell which one. And remember we have those 3 right now: translation, reflection, and rotation. If it's not, explain why. So on number 1 with the arrows there, I would say yes, that is a rigid motion because the location has changed, but the size hasn't changed. It's the exact same size, it's just turned to a different spot. Number 2, that one is not a rigid motion, and sorry, my video kind of covers that up there. But it's not a rigid motion because it does not include a change, or a rigid motion should not include a change in size, right? We know that rigid motions should just stay the same size, okay? So because it's getting bigger and smaller, it's not a rigid motion. Okay, example 3, you may need some graph paper to do this, and I'm going to send out some graph paper, printable graph paper, or maybe you can just kind of sketch it gently into your notebook. But look up at number 3 at the top. It has a rule there for us, so we need to know, what does that rule mean and how does it apply to the shape that we're looking at? So the T tells us that we're translating or we're moving all of the points, and then that -5, -2 there tells us that we're moving it -5 in the X direction and then -2 in the Y direction. So here's kind of my what this means up here. So -5 means that I'm moving it 5 units to the left, right? Think about the x-axis and where we're moving things. -5 is to the left. And then for -2 for the y, that means on the y-axis that I'm starting at 0, I'm moving everything 2 down, okay? So now instead of starting at 0 like we would with the normal point, I'm going to start at the point that I want to move. So I could start at point W up here, for example. I'm going to move point W 5 units to the left. 1, I'm going to try to hop here with my really bad pointer. 1, 2, 3, 4, 5. And then I'm going to move point W 2 units down. 1, 2. So I'm hoping that my new point W is going to end up right about there. Sorry, that's awful. That means every single point, there are 4 points there. I'm going to move 5 units to the left and 2 units down. So my next point I want to take is X. I move it 1, 2, 3, 4, 5, and then 1, 2 units down. There'd be my new X prime. I have this typed up, so I'm just going to go ahead and show you where my new points would be. So see how I took my point V and I moved it all the way over 5 to the left and 2 down, and then took Y, moved it 5 to the left and 2 down. And then when I redraw that, it creates this new shape, right? This new kind of quadrilateral that we're looking at here. I'm going to get rid of all of these extra lines because when we do our transformations, we really just want to see where's the pre-image and where is the image. So remember that this guy right here, my starting point is the pre-image. That's what I started with. And then over here, this is my image or my ending point, okay? In my core classes, when I've taught this, it's often really helpful for students to write pre-image and image within their shapes, just to kind of remind them. So remember also that we're going to call these points W prime, X prime, V prime, and Y prime for the new shape. So take a minute if you need it. Example 4 is just another type of a translation, right? It tells us by that little t, it wants us to translate each point 6 to the right because now our 6 is positive, and then 4 units down because our y is still negative. So when you see that little x, y, that basically just means any point that we're going to start with. So r, for example, r is point, I think it's -4, +4. I'm going to take all those points and move them 6 to the right and then 4 units down. So instead of showing you my really ugly pointer here, I'm just going to show you my new points. So if you look at point R prime that I have graphed there and you count it out from my pre-image, and remember that this guy right here is my pre-image, it's what I'm starting with. From my pre-image, I've moved point R prime 6 to the right and 4 units down, okay? Same with Q to Q prime, I've moved Q 6 to the right, 4 units down, and there's my Q prime, and then I move my S 6 to the right, 4 units down, okay? So I can connect all the points, and there is my image or my final ending point after I've done my translation. So that's all for today. If you need to, please do go back and look at the examples again, and you can also flip through the textbook and see if the textbook has any good examples for you. I'll attach some extra resources as well in the links below. That's so fancy. I feel like a YouTuber. I've always wanted to say that. So anyway, today's assignment is page 550. Take a look at the numbers that are there. You are going to need graph paper and a straight edge to do these. So I wish I had like a whiteboard to show you. I guess I could maybe go back and show you, but I always have students who they start with these really nice triangles and then they draw out something like that looks like that for their image. Don't have images that look like that, you guys. Use a straight edge, make them really nice and neat, make them look really good and professional. We are in 10th grade class. If you need graph paper, I have, I'm going to attach them to the email that I'm sending out to you guys so you can print it off. And if you don't have a printer, you're just going to need to figure out some way to kind of sketch small graphs into your lined notebook paper. I would highly recommend, I'm not going to require it since I'm not grading this homework, but I'd really recommend that you start with your pre-image in pencil. So just kind of sketch out the points that you're starting with, and then the image, draw it in a different color. Okay, so highlight it or use colored pencil or do something so you can see here's where I start and here's where I end, and they're two different shapes. Okay, that's all for now. If you have any questions, you know where to find me. And yeah, that's all for now. See you later.